Hello, this is Mrs. Davis. I am going over AP Pre-Calculus Unit 1.8, Rational Functions and Zeros, and this is the second video. We're tackling a different topic right now, but it's still involving rationals. It's just about inequalities now. And so, you know, inequalities are different. When you have polynomials, you have to use like a sign chart, and solving rationals, you have to do that also. And so we're going to practice some of that. Now, this little bit here walks you through the steps, so let's just read through those together. The first thing you need to know is when you're solving rational inequalities, you need to identify both the zeros and the undefined values. So everything that makes a zero on the top in the numerator and the denominator gets put on your sign chart. So first off, you have to make sure the inequality has 0 on the right-hand side or left. You make sure that you have a single rational function. Now you set the numerator equal to 0 and take the denominator, set it equal, and use those to make a sign chart. Make sure to factor so you can do the sign chart right. And so you create a sign chart, and then be careful to mark the values where h is 0. So the numerator 0, that's where it doesn't exist. So we don't include those in our solution. So test values, you've been seeing me do that. And interpret the chart to answer the question. And remember, for now, they want us to do interval notation. And we have to think about, is this included or not included? And I'll be talking that through. So let's look at the first example here. We have, it's already factored, and it's already has 0 on the right-hand side. If it were me, I would be pointing out that I have a greater than or equal inequality, so I'll try to remember that. And now I'm going to make my sign chart by setting each of these numerator and denominator equal to 0. So I would have a mark at -6, and I'm going to put a little dot there because that does not exist. Like, I can't, it's an asymptote, so we would never use a hard bracket, I guess. You'll see. And then at 2, and it doesn't matter spacing here, and at 3. It really doesn't matter. You're just trying to get your intervals there. We're not making a number line. All right, so the first thing I'll do is I'll try -7. Now remember how we do this. We're going to test -7 in the top, so that would be -7 minus 2, so that would be negative. And then -7 plus 6 would be negative, and -7 minus 3 would be negative, which makes this whole side here before 6 negative. Then between 6 and 2, let's pick 0. It's the easiest thing. So if I put 0 in for x minus 2, I get 0. And if I put 0 in for x plus 6, I get positive, and then negative for x minus 3. And I put 0 up here, and I was supposed to put whether it was positive or negative. Okay, so let me erase that. If I put a 0 in, it's negative. So I have negative over negative. That will make this part positive. Now between 2 and 3, I have to pick 2.5. But remember, we're not solving it. We're just trying to figure out it's positive and negative. If I put a 2.5 up here on x minus 2, I would get a positive on the top this time. 2.5 plus 6 is going to give me a positive, but 2.5 minus 3 is going to give me a negative. So this whole side would be negative between 2 and 3. Okay, and then have to go past 3. So put in 4. 4 minus 2 is positive. 4 plus 6 is positive, and 4 minus 3 is positive, making this whole side positive. All right, and I made this a little big, so I need this room. This was 2.5, so that would be positive. Okay, so now we have to look at our sign chart to see what parts are greater than or equal to 0. So I'm going to get my highlighter out, and greater than or equal to, oh, one other thing. I didn't put my dot under my other 0, which is right here. Okay, so just remember, you can't use hard brackets for those. So I am greater than or equal to 0 here. Okay. 2 would be included, and then from 3 on, but 3 and 6 would have to have your soft bracket. So we would say -6 to 2, hard bracket, union 3 to infinity. Remember, our function does not exist at x equals -6 and does not exist at 3. That's why those are soft brackets. But this 2 was a 0, so it is included because another reason is it was greater than or equal. Now, you don't have to worry about soft brackets, hard bracket if it's just greater than or less than, because you would never use hard brackets or square brackets. All right, let's look at example 6. We have, notice it's less than 0. We don't have it factored, but it is set, everything's set to the left and 0 to the right. So let's factor this. So we're going to say this is x plus 2, x minus 2 over x minus 5 quantity squared. So, okay. So that's what we're going to have. And we have nothing to cross out, no holes. So I have plus or minus 2 on my sign chart. So I'm going to go way down here. I have plus or minus 2, so -2. I'll just put that there, 2. And then here I have 5. So I have -2, 2, and 5. Okay? And a lot of times these are called the critical points. I haven't talked about that yet, but some textbooks would already have called those the critical points for this rational function. All right, let's start testing. So testing negative, more negative, so that'd be -3. And I'm up here, -3 plus 2 would be negative, and then -3 minus 2 is negative, and bottom is always going to be positive, so I could just go ahead and do that. No matter what you put in, you're going to get a positive number in the bottom. So that's kind of nice. So if it's negative over positive, that's going to be positive. Then let's try 0, which sits in there. So I have 0 plus 2. I'm back here. I have a positive. 0 minus 2. Let me get closer. 0 minus 2 would be negative. So I have a positive, negative, which is negative. Negative over positive, making this negative. All right, next one, I'm putting in, let's put in 3. 3 plus 2 is positive, and 3 minus 2 is positive. And so I have a positive over positive, so this is positive. And last one, I have, I think I have messed up. No, I haven't messed up. That should be +5, right? This is x minus 5 squared, so that would be a +5. Okay. Yeah. Okay, so when I go to 6, say, I get 6 plus 2 is 8, positive. 6 minus 2 is still positive, over positive. So this is positive also. But it wants to know where it's less than 0. And the only place I have it less than 0 is right here. Now let's mark the zeros. The asymptotes. I had an asymptote here. So that doesn't really affect it. But it's still less than. So because it's less than, everything's soft bracket anyway. So I would have -2 to 2. Oops. -2 to 2 as my interval and my answer to where that's less than 0. All right, let's move on to example 7. Everything's all factored. Everything's on the right-hand side. I just have a greater than, so I don't have to worry about soft bracket, hard bracket. Actually, this sign chart's really easy. If you put a 3 in here, if you put a 2 in, you're going to get a negative. And if you put a 4 in, you're going to get a positive. So where is it greater than 0? It would be from 3 to infinity. And now that 3 is a soft bracket because it's less than, not less than, greater than, not greater than or equal. And let's look at example 8. Doesn't really matter about this factoring, but we'll do it anyway to get in the habit. 4 times x plus 2 over x plus 5, still less than or equal. Now we have less than or equal, so hard bracket, soft bracket's going to matter. Let's get everything I need, all my, as we say, critical points here. I have a -5 and a -2. All right, and so -5 is going to be my asymptote, so you can't use a hard bracket there no matter what. All right, so let's start doing a sign chart. All right, so do this, the divisor sign. If I put in more negative, so -6, I get -24 plus 8, so that's going to be negative, and -6 plus 5 is going to be negative, so I end up with a positive right here. If I go between -5 and -2, let's say -3, I have -12 plus 8, so it's going to be negative. And -3 plus 5 is positive. So a negative over positive is going to be negative here. And lastly, if I pick, say, 3, well, let's pick 0 because I'm at -2 here. 0 would be positive on the top, it'd be 8. And on the bottom, it'd be positive 5. So we have positive. So now we can say, where is it less than or equal to 0? So it would be where I have my negative signs. Now, this doesn't exist at 5, so it's soft bracket -5, comma, but it does exist at 2, so 2 would be my hard bracket. So not 2, -2. So -5, -2 is the solution. And lastly, let's just look at example 9. We have a graph here, and it shows some asymptotes, and it wants us to solve these inequalities. So we're just going to be reading off the graph. So first of all, where is f of x less than or equal to 0? So less than or equal to 0, it looks like this is all positive, and this is all positive. So this is the piece that's going to be less than or equal to 0, and this piece. Now, there's no asymptote at where it starts going negative, which is -1 and which is 2. So those are both going to be hard brackets, but it doesn't exist at -3. So I have to say from -3 to -1, hard bracket -1, and then again it starts to go negative again at 2 and goes to 3. So 2, 3, 3 is not included because it's an asymptote. So we have -3 to -1 and 2 to 3. All right, now let's erase that and figure out where it's greater than 0. Now, not greater than or equal to 0, but greater than. Now we have a lot of pieces that's greater than. This is greater than 0, this is greater than 0, and this little area in here would be greater than 0. So let's start talking about that. We have -infinity, and then it has to stop at -3. And then let's do the little piece in the middle. We always kind of go left to right in order for our intervals. So it's greater than 0, so we would use not greater than equal, so it's going to be a -1 to 2, both soft brackets. This is just greater than. And then 3 to infinity, it would still be positive. All right, and last one. Where is it greater than 1? Greater than or equal to 1? Well, it's never going to be equal to 1. I'll show you. This is the asymptote y equals 1, and there's an asymptote there, so it's never going to reach 1. So we just have to say those two pieces that are greater than 1. So we have -infinity to -3, and then we have 3 to infinity. All right, so that's lesson 1-8. Not a very hard lesson, kind of fast. I will work on the next video.